All right, ready for some old school algebra. So we're going to say expand 5 plus h cubed, which is 5 plus h times 5 plus h times 5 plus h. And we have to do all kinds of FOIL stuff. This one times this one, this times that one. And we get 5 cubed plus 5 squared, 3 times 5 squared times h plus 3 times 5 times h squared plus h cubed. You might remember a pattern of coefficients like 1, 3, 3, 1 from Pascal's triangle. This is basically the only time we're going to have to expand that. So if you want to fill in all those steps, you can, but it's not a big deal. So we've got that expanded. And then we're going to go back and say f prime at 5 equals this limit, h goes to 0. So we're saying, how does this thing behave as h goes to 0? Of 5 cubed plus 3 times 5 squared times h plus 3 times 5 h squared plus h cubed all over h. And remember, there was a minus 5 cubed here. So now let's do algebra on this. Well, the first thing I notice, I'll get out my canceling pencil. I've got a plus 5 cubed and a minus 5 cubed, so I can cancel those. So I get the limit as h goes to 0 of 3 times 5 squared h plus 3 times 5h squared plus h cubed all over h. And what can I do now in terms of canceling? Well, I've got an h in this term and an h in that term and an h in that term, so I can cancel. So I'm going to say cancel the h with the h there. With just the squaring part of the h there, it becomes a 1, and the cubing part, it becomes a 2. So I get the limit. Now I don't have a denominator anymore. 3 times 5 squared, the h got canceled, plus 3 times 5h plus h squared. Now going from here to here is technically a big mathematical step, because here we had a danger of divide by 0, and here we don't. So there we need a theorem from the limits chapter. And we'll see that when we get to the chapter about limits. But now, if I plug in 0, what happens? Do I get a divide by 0? Nope. So I can just plug in 0. Plug in h equals 0. I get 3 times 5 squared plus 3 times 5 times 0 plus 0 squared, which is just 3 times 5 squared, which is 3 times 25, which is 75, which is pretty much what we were expecting based on our work in Desmos or Excel. So altogether, we've seen that f prime of 5 equals 75. And we can say, we pronounce that as the derivative of f at 5 is 75. Or you could say we differentiated, that's the word for taking the derivative, we differentiated, differentiated f at 5, and we got 75. Or you could say the instantaneous rate of change of f at 5 is 75. All right, so what was hinted at by the Desmos and Excel work we did, we've now actually shown with algebra, kind of skipping over some of the theoretical parts. And then in the next video, we'll talk about a way to go and use that to do a nice approximation of f.